Now we have the next problem. Find the ratio in which the line joining A and B is divided by x is equal to 7 at P. Hence find the coordinates of P. Now in this case, we are given 2 points A and B with coordinates -5, 2 and 10, 6. We are also given that there is a line x is equal to 7 which divides AB in a particular ratio which we'll need to find, and also given that it's meeting at the point P. Now let this point P have coordinates x, y. Now since P is on the line x is equal to 7, the x coordinate for the point P will be 7. So we have the point P as 7, y. Now we need to find the ratio in which it divides. So by section formula, we have x is equal to mx2 plus nx1 upon m plus n, that is 7 is equal to m into 10 plus n into -5 upon m plus n. Cross multiply to get 7m plus 7n is equal to 10m minus 5n. Take m's on one side, n's to the other side. We have minus 3m is equal to minus 12n. Now we'll do m upon n. We get m upon n is equal to minus 12 upon minus 3. That is m upon n is equal to 4 upon 1. So we've got the ratio m is to n as 4 is to 1. That is, the point P divides AB in the ratio 4 is to 1. Now we want to find the y coordinate for the point P. So this can be done again by section formula. We have y is equal to my2 plus ny1 upon m plus n. That is equal to 4 into 6 plus 1 into 2 upon 4 plus 1. Simplify to get 24 plus 2 upon 5, that is 26 upon 5. So we have the y coordinate of the point P as 26 upon 5. So the coordinates of the point P will be 7, 26 upon 5. Now let's look at our next problem. If 2, 1, minus 1, minus 3 and 4, 5 are the midpoints of the sides of a triangle, find the coordinates of its vertices. Now here we are given the 3 midpoints of the triangle. Let us take the vertices as A, B and C with coordinates x1, y1, x2, y2 and x3, y3. Now let us take the first midpoint D as 2, 1. Now D is the midpoint of AB. So by midpoint formula we have 2 is equal to x1 plus x2 upon 2. That is x1 plus x2 is equal to 4. We number this as equation 1. Now same way we'll take the y coordinate. We have 1 is equal to y1 plus y2 upon 2. That is y1 plus y2 is equal to 2. Now number this as equation 2. Now E is the midpoint of BC. So again by midpoint formula we have minus 1 is equal to x2 plus x3 upon 2. That is x2 plus x3 is equal to minus 2. We number this as equation 3. Now same thing we'll do for the y coordinate. We have minus 3 is equal to y2 plus y3 upon 2. That is y2 plus y3 is equal to minus 6. Number this equation 4. Now F is the midpoint of AC. So we have 4 is equal to x1 plus x3 upon 2. That is x1 plus x3 is equal to 8. Number this as equation 5. Now one more equation. We take the y coordinate. 5 is equal to y1 plus y3 upon 2. That is y1 plus y3 is equal to 10. Number this as equation 6. Now we have 6 equations with 6 unknowns: x1, x2, x3, y1, y2, y3. Now since we have 6 equations with 6 unknowns, we will be able to solve them simultaneously and get their values. First we will find x1, x2, x3. So we take the equations 1, 3 and 5. Now from equation 1, we have x1 is equal to 4 minus x2. And from equation 3, we have x3 is equal to minus 2 minus x2. Now we substitute these values of x1 and x3 in equation 5. We get 4 minus x2 plus minus 2 minus x2 is equal to 8. That is 2 minus 2x2 is equal to 8. Simplify this to get 2x2 is equal to minus 6. So x2 is equal to minus 3. Now using this value of x2, we can find x1 as 4 minus x2, that is 4 minus of minus 3, which gives us 4 plus 3, that is 7. x3 will be minus 2 minus x2, that is minus 2 minus of minus 3, which gives minus 2 plus 3, that is plus 1. So we've got x1 as 7, x2 as minus 3 and x3 as 1. Now in the same way, we will find the values of y1, y2 and y3. To do that, we will take the equations 2, 4 and 6. Now from equation 2, we have y1 is equal to 2 minus y2. And from equation 4, we have y3 is equal to minus 6 minus y2. Now we substitute these values of y1 and y3 in equation 6. We get 10 is equal to 2 minus y2 plus minus 6 minus y2. Simplify this to get 10 is equal to minus 4 minus 2y2. That is 14 is equal to minus 2y2. So we have y2 is equal to 14 upon minus 2, which is minus 7. So we've got the value of y2. Using this value, we can find y1 and y3. Now y1 is 2 minus y2. That will be 2 minus of minus 7, which gives us 2 plus 7, that's 9. And y3 is minus 6 minus y2, that is minus 6 minus of minus 7. We have minus 6 plus 7, which is 1. So we have got y1 as 9, y2 as minus 7 and y3 as 1. So the required vertices A will have the coordinates as 7, 9, B has coordinates minus 3, minus 7 and C will have coordinates as 1, 1. So we have finally found out the 3 vertices of the triangle ABC. Now we look at the next problem. We have if A, B, C are given to us, find the coordinates of D so that ABCD is a square. Now we are given a square, let's draw that, and we are given the vertices A, B and C. We want to find out the coordinates of the fourth vertex D. Now we know that in a square the diagonals bisect each other. Here we have AC and BD are the diagonals. They intersect at the point M. So M is the midpoint of AC and also for BD. Now let's find the coordinates of the point M. Let us take the coordinates of M as x, y. So by midpoint formula we have x is equal to minus 5 plus 5 upon 2, that is 0 upon 2, which is obviously 0. Now the y coordinate will be 4 plus 2 upon 2, that is 6 upon 2, which is nothing but 3. So M has coordinates 0, 3. Now we want to find the coordinates of the point D. Let it have coordinates as x4, y4. Now again by midpoint formula, we will get 0 is equal to minus 1 plus x4 upon 2. Now 0 into 2 is 0. So 0 is equal to minus 1 plus x4, that is x4 is equal to 1. Now to find the y coordinate, we'll do the same thing. We have 3 is equal to minus 2 plus y4 upon 2. Cross multiply. We have 6 is equal to minus 2 plus y4. So we get y4 is equal to 8. So the point D will have coordinates as 1, 8. Now we have the next problem as the line joining P and Q intersects the y-axis at R. PM and QN are perpendiculars drawn to the x-axis. Find the ratio PR is to RQ. Also find the coordinates of R, and we are also asked to find the area of the quadrilateral PMNQ. Now let's draw the figure for this. We draw the x-axis and the y-axis. We mark the points P and Q. Draw the perpendiculars PM and QN to the x-axis. Now, first part, to find the ratio PR is to RQ. Now it's given that R is a point on the y-axis. Let us take the coordinates of R as x, y. But R is on the y-axis, so the x coordinate of R will be 0. That is, the coordinates of the point R are 0, y. Now we want to find the ratio. That can be done using section formula. Now let the ratio which we are asked to find be m is to n. So by section formula we have x is equal to mx2 plus nx1 upon m plus n. But the x coordinate for R is 0. So we have 0 is equal to m into 4 plus n into minus 6 upon m plus n. Now m plus n into 0 gives us 0. So we have 0 is equal to 4m minus 6n. That is 4m is equal to 6n. Take m and n on one side. We get m upon n is equal to 6 upon 4. That is nothing but 3 upon 2. So we've got the ratio m is to n as 3 is to 2. That is the ratio PR is to RQ is 3 is to 2. Now the second part in this is to find the coordinates of point R. Now we already know the x coordinate of the point R is 0. Now we can find the y coordinate using section formula. We have y is equal to my2 plus ny1 upon m plus n. Now we already know the ratio m is to n as 3 is to 2. We substitute that here. We have y is equal to 3 into 5 plus 2 into 4 upon 3 plus 2. Simplify this further to get y is equal to 15 plus 8 upon 5. That is y is 23 upon 5. So this is the y coordinate of the point R. So R will be written as 0, 23 upon 5. Now the third part in this sum is to find the area of the quadrilateral PMNQ. Now this quadrilateral is actually a trapezium, and we know the area of a trapezium is half sum of the parallel sides into distance between them. So we have area of this quadrilateral as half into PM plus NQ into MN. Now PM we already know it is 4, NQ is 5. Now what will MN be? MN will be 4 plus 6, that is 10 units. So substitute that here to get half into 4 plus 5 into 10. Simplify this to get half into 9 into 10. That is nothing but 45 square units. So the area of the quadrilateral is 45 square units.